Hello! Today, I'm doing my last day of learning GDScript from 0. So, I've already done lessons 1 to 20 in the past 2 days, and I will finish it up with lesson 21 to 27. So today I will cover functions that return a value, appending and popping values from arrays, assessing values in arrays, creating dictionaries, looping over dictionaries, value types, and specifying types with type hints. So yeah, I will start with 21. So functions that return a value. Until now, you learned that functions are sequences of instructions you give a name and you can call anytime. On top of that, functions can make calculations and return new values. Let's look at some examples to see why it's useful. Built-in functions that return a value. Many functions built into GDScript make calculations and return a value. For example, the round function makes a decimal number as an argument and gives you back a new number rounded to the nearest digit. So func run var number equal round 3.4, so it would round 3.4 to 3, I think. Yeah. So imagine you have a game where you track the player's health as a percentage, a decimal number going from 0 to 100. When displaying the health on the interface, you don't want to show the decimal part. In that case, you may use the round function like so. Oh, okay. Got it. Okay. Notice how we assign the results of the function called a var. Oh wait, I should read this. So var rounded health equals to round health set text rounded health. What's set text? I don't know, maybe I'll learn that after. Notice how we assign the result of the function called to a variable. Because the round function returns a new value, we need to either store the result or use a value immediately. Above we assign it to a variable, but you could also do so the following. So set text round health. Okay, you can assign the return value of a function, call it if you plan on using it more than once. So you can assign the return value of a function. You can assign the return value of a function, call if you plan on using it more than once. Okay. A cooler example, lerp. The lerp function, I never heard of lerp before. The lerp function is shorter for linear interpolate. That sounds familiar, but I don't remember what that means. Calculates and returns a weighted average between two values. It takes 3 arguments, the 2 values to average, and a value between 0 and 1 to skew the results. In game programming, it's used to animate things moving toward a target with a single line of code. So func process delta position equals lerp position get local mouse position times. Oh, what does that mean? Okay. So position equals to lerp calculates and returns a weighted average between 2 values. Okay, so it takes a position, get local mouse position, and then 2 times delta. I need to know what those arguments are then. Okay, every frame the code calculates a position somewhere between the turtle and the mouse cursor. The lerp function takes care of everything. Wait. What do you mean I made what? No, I did not. Huh? Wait, what's the AFK mob? Huh? I'm confused. You're confusing me. lerp's confusing me and now you're confusing me. Okay. Every frame the code calculates a position somewhere between the turtle and the mouse cursor. The _lerp function takes care of everything. So it takes the position somewhere between the turtle and the mouse cursor. The _lerp function takes care of everything. So it takes the position of the turtle, takes the mouse position, and that's something to do with the movement, I guess. Oh, the mob that follows you around. Oh. Oh, that's true. That's what this is, yes. It makes me think of that too. Now that you mentioned that, yeah. Yeah, it's like, if you're there, then it follows you. True, true. And it's just one line of code. Alright, writing a function that returns a value. You can make your functions return values. To make a function return a value, you use the return keyword followed by the value in the question. In the previous lesson, we have characters walking on grids. And for those practices, you are working directly within cell coordinates. While cell coordinates... Oh my gosh. Well, cell coordinates don't correspond to positions on the screen. To find the center of any cell on the screen, we need to convert the cell coordinates to a position on the screen in pixels. Okay. Okay. And then, to do so, we use a function. The function does two things. First, it multiplies the cell coordinates by the cell size, which gives us a position of the cell's top left corner of the screen in pixels. So it multiplies the cell coordinate by the cell size, which gives us the position of the cell's top corner. Okay. And then we add half of the cell size to get the center of the cell. Okay, that makes sense. The function returns the results allowing us to store it in a variable. So cell size is vector 120 by 120. So this is 120 by 120. Then convert to world coordinate cell. So return cell times cell size. So this is the first cell, let's say, times cell size plus cell size. So let's say this is the first cell times the cell size, which is 120 plus cell size. Oh, okay, got it. So this is, let's say, for example, the first cell is 0 times cell size, which is 120, but it turns into 0 plus 120 divided by 2. And then in this one, it'll be 1 times 120, so it's 120 plus 120, so it's 240 divided by 2. So this is what? Wait, did I math wrong? 1 times 120, which is 120 plus another 120, which is 240 divided by 2 should be 1. How does... Okay, yeah, math is hard. I don't know how is it 180? How is it 180? Where does the 180 come from? 180? Oh wait, this is not in bracket. Okay, this one first. But wait, no, but then doesn't programming, it doesn't take bed mass. It takes like whatever it reads first, no? So it takes this and then that and then that, no? Does it take bed mass? Is it supposed to be like this? But that doesn't make sense. Wait, does it make sense? Okay, so this is 120 divided by 2, so it's 60. Yeah, that would make sense if it takes bed mass, right? But is it... I don't know. Does it take bed mass? I don't even know anymore. I thought, okay, alright, correct me if I'm wrong, but I remember programming having to just read from left to right. I did not know that it takes the multiplication and division first and then add, but okay. Well, next. The return keyword returns the value to the code calling the function. You'll receive the result when you call the function. So var cell size equals to vector 2, 120 by 120, function run var world position equals to convert to world coordinates vectors 1, 1. Print world position. So that is vectors 1, 1 is this one. So that way it prints that one. Okay. Yeah, math is hard. Some functions return values and some do not. During practices, you can learn which function return a value using the documentation panel. It will display if the practice requires using some specific functions or variables. There are functions that start with a term void do not return a value. Any other terms mean the function does return a value. You'll learn more about what other terms mean in a couple lessons when we explore value types. For now, let's practice returning values from functions. Okay, on a side note, I like to use brackets. So this really throws me off because I'm just reading from left to right, okay? And I'm pretty sure normally it should not be smart enough to just figure out which one is multiplication and division first. But I don't know. Hello. Welcome. Alright, so converting coordinates from the grid to the screen. Goals. Define a function that converts a position on a grid to the screen. The function takes a vector 2 cell coordinate as an argument. It should return the corresponding vector 2 screen coordinates at the center of the cell. So yeah, I forgot what the function was. But do I have to calculate it? Define a function that converts to the screen. Takes the vector 2 cell coordinate as an argument. It should return the corresponding vector 2 coordinate. Okay, so it's returned. And then it takes the cell. So let's say it takes 0, 0. It takes 0, 0, so it should be that. 80, 80. So it should be... Do I need to do like... No, I'm not interested in artworks and stuff. I'm okay though, thank you. Convert to world coordinate cell. So cell size, let's see. Cell size is 80 by 80. Can I just multiply? Can I just do like return vector 2 equals to cell size dot x times cell plus 1. Does it work like that? Can I do it like that? And then cell dot x and cell dot y. Should be like that, right? Because it takes the thing x and y coordinate, cell size x is 80 times cell X, which is 0 plus 1, which means, okay, I think it's this. No? Wait. Oh, center. Oops. Alright. The function takes a... Oh. I didn't read it properly. Cell coordinate as an argument should return the corresponding screen coordinate at the center of the cell. So, at the center of the cell means that it was a thing earlier. Alright, I'm gonna do it my own way. Vector 2. If I want to take the center, it'll be the middle first. So it'll be cell size. Let me put it here for now. Cell size divided by 2. Alright, I'll just do x coordinates for now. Cell size divided by 2. Then cell size divided by 2. Oh yeah, it's pretty much the same. Okay, so what they did earlier was this. Cell size divided by 2. And then it'll be cell times cell size. I think it's this. Right? Yeah, okay. I'm good. That was a struggle. Okay. Append and popping values from arrays. In previous lessons, you learned how to create arrays to store lists of values and how to loop over them. It's nice, but you won't go far with only that. The real strength of arrays is that you can add and remove values from them at any time. It allows you to queue or stack data. For now, let's take another example. Tracking orders in a restaurant management game. You're making a restaurant management game where customers place orders and you need to handle them as they come. In this game, customers order meals that end up in a queue. You need to prepare them in the kitchen. In this example, we simulate orders arriving and getting completed over time. Run. Tomato soup. Toast. Burger. Cheese. Sandwich. Tomato soup. Toast. Oh, okay. Oh, and that goes there. Got it. How do you keep track of pending and completing orders within an array? When a customer purchases a meal, you want to append it to the array. Then, as you complete a meal in the kitchen and serve it, you want to remove it from the array. You can do that with append and pop front functions in the array, respectively. Try to read the code below before moving on. Don't worry if not everything makes sense, as we'll break it down. So, waiting orders, an array, completed orders, another array, and then func add order meal name. So waiting orders, so this one, append a meal name, and then func complete current order, which is var first order equals to waiting order pop front. So what it does is it takes the front one and also removes it at the same time. It can do that? Does it do that? You can do that? It just pops the first one and stores it in a... Huh? You can just do that? Because doesn't this just store the array? Without a thing? Okay, waiting orders is this one, and then it pops, I guess it pops the first one, and then completed orders append the first order. But I guess in this one it just this throws me off. Because when I understand this, what this does is it's supposed to very first order becomes a variable that is an array with the first index being removed. But I guess it doesn't work that way. It just, what this does, it just removes the first one and stores it into that. It's like 2 lines in one. I don't know. I've been so out of the loop for programming. There's so, I guess it's new stuff that I didn't know was possible. Alright, notice how we call some functions by writing a dot after a variable name. Like a given value type can have subvariables, it can also have its own function. So function like append and pop front only exist in arrays. That's why to call them we need to access it from array using the dot array.append. Let's break down the code. So we queue orders in waiting order array by appending them to the array. So var waiting order an array, and the func add order meal name waiting orders dot append meal name. So it adds the name to the array. We can use a string to represent a meal when calling the add order function. So add order cheese sandwich. So it calls this function and then it adds cheese sandwich to it. When completing an order, we remove it from the waiting order array by calling its pop front function. This function gives us the order back, which allows us to assign it to a temporary variable. I guess that's just how this function works. It's a very interesting function that I first time knowing that this exists. We can then append the order to our completed orders array. So pretty much the array completed orders func complete current order, and then completed orders dot append first order. So it appends this one. We call arrays like waiting orders a queue. The first element we append to the array is the first one we remove. So what does ## mean? Whatever you call that symbol. I don't know what people call that symbol nowadays, but yeah. We write that to represent ellipses in the code, which means we're completing a function's code. We use that to break down code examples and make them easier to learn from. The hash sign, oh okay, I guess you call it the hash sign. The hash sign itself marks the start of a code comment. It's a line the computer will ignore, which is why it typically appears in gray. Using arrays as stack. Another common use of arrays is stacks of data. Take a factory management game where you need to retrieve materials from stacks of crates. They arrive at the factory piled up vertically and you need to take them from top to bottom. So, var crate healing heart shield sword. So, func. Oh, okay. So func use top crate, var crate equals to crate dot. Oh, crates dot pop back, and then use crate. So pretty much, it stores crate with the last thing, so sword, and then you use it as an action, I guess. But yeah, to take a crate from the back of the array, this time we use the pop back array function. This function removes pops, and this function removes or pops the last value from the array and returns it to you. Here we pop the last value of the array and print what's left of the array to demonstrate how the array gets smaller. So for this one, it says var crates is equal to sword shield gems, and the func run crates dot pop back. So it pops the gems away, and then it'll have sword and shield left. Yep. So like pop front, the function returns a value removed from the array. You will often store that value in a variable. The value in question could be crate's content, which you can then use to give resources to the player. In the following practices, you will use the append, pop front, and pop back array functions. Alright, I'm ready. I need a little water though. Okay. There. The waiting orders array will be filled over time. Your job is to move orders from the waiting list to the completed orders list using the array's append and pop front function. Remember that the array's pop front function returns the pop value, which allows you to store it in a variable and then pass it to another function. So complete current order. So var current order is equal to waiting orders dot pop front, and then I use it. It's telling me to use the pop front. Okay. Waiting order used over time. Your job is to move the order list to the completed order list by using the... Okay, so, and then I do... Oh, how does the append work again? Is it like completed orders dot append the current order, right? Do I need to return anything? Okay, let's run it. Nice, I did it. Easy. Okay, clearing up the crates. Crates are piling up on the platform. Move them out of the way by popping them from the crates array. You need to remove them from top to bottom using the array's pop back function. Your code should remove all crates in the array while using a while loop. Careful if you run a while loop carelessly. You can lock the software. You can check if the crates array still contains values by writing while crates. Okay, so it's telling me to do while crates, and then crates dot pop back. Do I need to store it anywhere? Crates are piling over the line. You need to remove from the top to the bottom using the array's pop. Your code should remove all the crates using a while loop here. Okay, so it's just getting rid of them. So run. Yep, nice. Lesson complete. Lesson 23. Accessing values in arrays. You learn to loop over all the values in an array using the for keyword. For value in array, print value. But what if you need to access the third item in the player's inventory, the 10th item? There's a dedicated notation to access one element in an array by index. To do so, you use square brackets with a number inside the brackets. Index 0 is the first element in the array. So, var inventory, shield, healing heart, gem, sword, shield, sword. Func, run, use item, inventory, 0. So it uses shield. Run. But there's no... It says there's 0 shield. Well, I guess that's not how it works, but yeah. Index 1 is the second element in the array, and so on. You should access the fourth element in the inventory array like so. So this one is inventory 3, so it uses that one. It uses the heart. Ding. Okay. How would you access the third item in the inventory array? It would be inventory 2. Indices start at 0, so the index of the third item is 2. That's why you need to write inventory 2. Accessing the last value with negative indices. What if you want to access the last or second before last item in the inventory? In that case, you can use negative indices. If you write -1 in brackets, you will get the last item in the array. You will get the second to last item if you write -2. So, because this is 0, the one at -2 would be the sword. Nice. Because it's using -2. That's very convenient when you need to quickly access elements from the end of the list. How would you access the third to last item in the inventory array? So it'll be this one. You're right, when using negative indices, -1 means the last element in the array. Index number -2 will be the second to last, thus -3 will be the third to last. It can be a little confusing as it seems to work differently from positive indices. However, it's because there's no differences between the 0 and -0. They both point to the first item in the array. You can't access non-existent indices. There's a catch with this syntax. If you try to access an index that does not exist, you will get an error. You have to be careful always to access existing elements in the array. There are a couple of ways you can check for valid indices. One of them is checking the array size. Check the size of the array. Checking arrays comes with the member function named size. You can call it on the array anytime you know its current size. So var inventory is healing heart, gem, sword, shield, and then run func run print inventory size. So it should print like 4, right? Yeah, prints 4. Because it's not counting the indices, it's counting the size. So the maximum index you can access an array is array size -1. That's the last item in the array. Yeah, because technically this is 4, so it'll be 0, 1, 2, 3 for the indices. So func run var last item index equals to inventory size -1. Use item inventory last item index. So it uses number index 5. Because the size is 6 and then it minuses 1, so it's 5, so it uses index 5. Okay. In the following practice, you will use array indices to realign train tracks and grab the correct item in an inventory. Oh, okay. In our game, the player has an inventory that works as an array under the hood. They want to equip a sword and a shield to buff their characters. Like before, you need to find them in the array. You need to access elements in the inventory array by index to do so. Call the useItem function with an item as an argument to use an item. For example, you can use the first item by calling useItem. So alright, they want to equip a sword and a shield to buff their characters. Like before, you need to find them in the array. So technically, inventory, wait, call the useItem function with the items as an argument to use an item. For example, you can use the first item by calling useItem inventory 0, but there's nothing in inventory. So what am I supposed to do? Correct items have been picked. Pick correct item amount. Okay. Well, I don't want to do this manually, right? You don't want to. Well, technically, I can use like, I can just go like use item, and then inventory, and then it'll be 1, and then it'll be like use item inventory 2, right? Because that's what it wants me to do, right? That's all it wants me to do. But like, that's like hard coding it. So like, shouldn't it be like if like while, or like for what is this? For an item in inventory, and then if, okay, if how does it check if there's a used item? Where does this go? Where does used item go? I don't know. I'm just gonna skip this. Whatever. Because I don't understand what else is in this code. Like it's easier to do it when I know everything. Okay. We have train tracks broken down on the little chunks in our game. We use them to make modular tracks and draw circuits of all shapes and sizes. However, several chunks are misaligned. You need to find them in the tracks array and pass them to the align function. To do so, you need to access the array by index. This time, though, you need to access them with negative indices. So, all other tracks are aligned to the grid. First track is well positioned. So like, you need to find them in the tracks array and then pass them to the align function. So it's telling me to just go like tracks -1. Like align tracks -1. I know, align tracks -2. No, align tracks -3. Is that what it's asking me to do? Oh, it's 4. So I need to do, okay. Okay, you know what? I'm gonna do 4 and in tracks. And then I do align. I'm just gonna align all of them. That's what I'm gonna do. Wait. For n in tracks dot size -1. Oh. Oh, sorry. Tracks. There. Wait. So I just need to do the last 4? Is that what it's asking me? So like tracks align tracks -4. This is like hard coding. 2 to line 1. It's asking me to do this. What's wrong with this one? This one? Like that? there. Happy. But like, however the several trunks are misaligned, you need to find them in the tracks array and pass them to the line. Like, what is it telling me to do? What can it do? Okay, so it's telling me to do the same thing pretty much. Okay, so I guess I did it right. Alright, 24. Lesson 24, creating dictionaries. In the last lesson, we used an array to represent a player's inventory. With just an array of item names, though, we can't easily keep track of the amount of each item. Instead, we can bundle the item names and amounts into a single dictionary. A dictionary is a data structure that allows you to map pairs of values. In the pair, we call the first value a key, as we use it to access the second. In other words, a dictionary has lots of keys, and each key points to a value. To define a dictionary, we use curly brackets. A colon separates each key and its value. A comma separates each key and a value pair. So it'll be dictionary equals to curly brackets and then key 1 colon value 1 and then key 2 colon value 2. Dictionaries can hold any values. Dictionaries can map about any value to any other value. For example, we can use the name of an item as a key and the amount as a corresponding value. This makes dictionaries excellent for keeping track of a player's inventory. So inventory, and then healing heart has 3, gems have 5, and sword has 1. Here we can match the name, a string, to the amount, a number, but a key could be a string, a number, or even a vector. Although we can have all these different keys, keep in mind that every key has to be unique. That means we couldn't have a dictionary like the following. Var inventory, shield 5, healing heart 3, sword 1, healing heart 8, because you can't have 2 healing hearts. We would get the following error. Error duplicate key found in dictionary literal. In the above example, which key would cause an error? Healing heart. You're right, the key healing heart appears twice in the dictionary. In the above example, Godot wouldn't know whether to return 3 or 8 when using the inventory healing heart. This is why keys need to be unique. How dictionaries work under the hood. Dictionaries are also called mapping or associative arrays. Under the hood, they use arrays and several functions to efficiently store and retrieve values across arrays. Precisely, dictionaries use a hashing algorithm. Hashing algorithms convert one value into another. In this case, hashing consists of converting a given key into a unique whole number. The dictionary then uses that number as an array index. That's how a dictionary works. When you give it a key, it converts it into a unique index and uses that index to retrieve the corresponding value in the computer's memory. That's also why you can't have the same key twice. It would map to the same array index, causing you to overwrite an existing value. Accessing values. We access the value of keys by writing the dictionary name and the key in between square brackets. So dictionary key. So var inventory equals to curly bracket healing heart 3, gems 5, sword 1. How would you access how many gems a player has? So it'll be how many gems the player has. It'll be var item count equals to inventory gems. You're right, you need to make sure the key is the same as we defined in the dictionary. In our case, var item count equals inventory gems is correct. Changing values. We can also change values directly, which is useful in our case for adding or removing items from the player's inventory. Func run inventory healing heart plus equals to 1, so it adds 1 to the healing heart. Add so much hearts. Okay. In the following practices, we'll use a dictionary to create a player inventory and create a function to change the value of items. Okay. So let's give some items to the player. We use a dictionary for the player's inventory. We define the inventory variable to you, but it contains no items yet. Give the player the following items by adding the correct keys and values to the dictionary. So healing heart 3. So healing heart, oh my gosh, I can't spell. 3, then comma, then gems 9, comma, and then sword sword 1, like that. The key should be string text and the values whole numbers. Nice. Continue. Increasing item counts. We want to change the item counts in the player's inventory whenever the player picks up or uses an item. We've started the add item function for you. The inventory dictionary should use the item name parameter as the key to access its amount. We should increase the value by amount. To test this practice, we'll use your add item function to increase the item count of healing heart, gems, and sword. So it'll be okay, add item. The inventory dictionary should use the item name parameter. So inventory dot item name and then plus equals to amount, like that. Nice. I want to I want to run it again. Wait, how do I don't see it running. Or maybe, I don't know. Maybe I missed it. It's okay. Continue. Lesson 25, looping over dictionaries. Like with arrays, you can loop over dictionaries. You can loop over both their keys and values. Let's see how it works with 2 examples. Displaying an inventory's content. To display the player's inventory, you need to know what it contains. You need the name and the amount of each object, and from code. You can also achieve that by looping over the whole dictionary and processing key value pairs one by one. To get the list of keys in the dictionary, you can call its keys member function. So var inventory healing heart 3 gems 5 sword 1 func run for item name in inventory keys, print item name. Okay, so it takes the inventory. So it takes the inventory dictionary and then takes the keys from the inventory dictionary and then it stores it into item name and then it runs in a for loop and print it out. So it'll print healing heart, gems, and sword. But it's something we do so much that you don't need to call the function. Instead, you can directly type the variable name in a for loop after the in keyword. Oh, okay, so you don't need to do the keys part then. Keys is just optional, I guess. The language understands that you implicitly want to loop over the dictionary's keys. So it does the same thing. That one does the same thing as that one. But it doesn't have the keys part, which still works the same way. You can use the values with the syntax dictionary keys as you learned in the previous lesson. We can loop over the inventory keys, get the corresponding values, and display all the information in the user interface. So func run for item and inventory, var item count equals to inventory item. So it takes the name of the key, it takes the key in the inventory dictionary and then takes the count because it's pointing to the index, pretty much. Yeah, and then print item name plus and then the colon string and count. You have to string that? I guess you do. Okay, so what it's gonna do is it's gonna print out all the items in there like that. So healing heart 3 gems 5 sword 1. Instead of printing the key value pairs to the output console, we can code and call a dedicated function that displays items in the user interface. So for item name in inventory, var item count equals to inventory item name. So it's the same as earlier, and then add item is item name item count. What does the add item do? What add item just adds? It's calling another function. Okay, sure. Mapping grid cells to units. We can also use a dictionary to map units to another position on a game board. That's how you typically code a board game, a grid-based RPG or a tactical RPG. While we focus on string keys so far, GDScript dictionaries accept any value type as key, allowing you to map anything to anything. The only limitation is that every key must be unique. So var unit cell vector. So the first one would be robot, second one would be turtle, and the third one would be robot. So you're storing that into each thing. Okay. Using a for loop, you can use the key value pairs to place units on the board at the start of a game. So func run for cell and unit cell. Var unit, the unit cells. Okay, for func run for cell and unit cells. Var unit equals to unit cell cell. So it gets the number, I guess. It gets the key. Okay. And then stores the amount in, or like whatever value is there, and then add unit, add cell, add the value to the cell, I guess. Okay, so in the following practice, you will loop over dictionaries and process their content. Okay. Displaying the inventory. We use a dictionary to represent the player's inventory. In this game, the dictionary keys are the name of items and they map to the number of items that the player owns. You need to loop over dictionary and display the name and amount of every item in the inventory. To do so, call the display item function. It takes two arguments, the item name and the amount. Let me reread that. Use a dictionary to represent the player's inventory in this game. You need to loop over the dictionary and display the name and the amount of every item in the... So display as in like, oh, using that function, display item. Okay. Okay, so for item in inventory, and then display item, and then it wants the string first, so it'll be item. Yeah, it takes that, the key, and then comma, and then it'll be inventory item, and that would be the count. Nice. Alright, placing units on the board. We have a dictionary named units that maps a cell, position on the grid to a unit to put there. Using a for loop and the place unit function, place every unit on the units dictionary at the desired position on the board game. We have a dictionary named units that map a cell position on the using the loop and the place unit function. So place unit takes the vector and then the unit type. Okay, so for unit in units, and then place unit, and then it takes a vector which is the unit, and then string would be, it's pretty much the same as earlier then, right? It'll be like units, then unit, like that. Nice. Continue. Value types. In your code, values have a particular type. We have already learned about several: whole numbers, decimal numbers, string, 2D vectors, arrays, and dictionaries. The computer uses the type of a value to know which operations and functions you can use with them. As a result, it's essential to understand types. They are not fully compatible with one another, and misusing them will cause errors. A prime example: you want to display the player's health in the interface. Your code tracks health as a whole number, a value type int, short for integer. So var health equals to 100. However, to display it on the player's screen, the computer wants text. It needs a value of type string. You can concatenate two strings with the plus operator. Okay. And then it goes hello there. So the following code looks like it could work at first glance. So it says display health, but health needs to be turned into a string. That's what the problem is, I think. Yeah, so when running the code, you get the strange error, invalid operand string and int and operator plus. Because either you display two integers and then it does the math and then display the number, but because this is a string, then this also needs to be converted into a string. It tells you that you can't add values of type string and they're incompatible. In that case, you need to convert the health number into a string, converting values into the string. You can get the text representation of a value by calling the str function, short for string. The function returns its argument as a new string. You can use this function whenever you want to turn some numbers or vectors into text. So var health equals to 100, func run, display health plus, and then convert that into a string. So it'll display health colon 100. Nice. In this case, it turns the number 100 into the string 100, or whatever number health is currently, converting strings into numbers. You can also convert strings into whole numbers or decimal numbers using respectively the int and float functions. Those functions can convert what the player writes in a text field into a number. For example, the number of potions to sell at once in a shop. So var player input 10, so it takes the string 10 and then var as whole number int player input that. So it converts the 10 string into an integer. So most types are incompatible. For example, you can't directly add or multiply an array with a number. However, some types are partially compatible. For example, you can multiply or divide a vector by a number. Okay, got it. So this will print vector 2 and then 10, 10. Nice. It is possible because other developers define the operation for you under the hood. However, you cannot directly add or subtract a number to a vector. You'll get an error. That's why in earlier lessons, you had to access the subvariables of position to add numbers to them. A surprising result. Take the following division, 3 divided by 2. What result would you expect to get? 1.5? Since this is like whole numbers, it's probably gonna display like 2, I think, or 1. Okay, displays 1. So well, for the computer, the result is 3 divided by 2 is 1, and then it says, wait, what? That's because for a computer, the division of 2 whole numbers should always result in a whole number. When you divide decimal numbers instead, you get a decimal number as a result. So this one would be 1.5 because it's decimal. Because it says func run print 3.0 divided by 2.0. Even if it's just a 0, adding a decimal place tells the computer we want a decimal number. This shows you how mindful you need to be with types. Otherwise, you will get unexpected results. It can get pretty serious. Number errors can lead to bugs like controls not working as intended or charging the wrong price to players. Understanding and mastering types is a key skill for developers. Programming beginners often struggle due to the lack of understanding of types. Languages like GDScript hide the types from you by default. As a result, you don't understand that some are incompatible. You can get stuck when facing type-related errors. You'll want to keep that in mind in your learning journey. When writing code, you need to understand everything that's happening. That said, let's practice some type conversions. Okay, displaying the player's health and energy. We want to display the player's energy in the user interface. Currently, our code has a type error. We're trying to display a whole number while the display energy function expects a string. Okay, use the string function clear the type error and make the energy amount display on the interface. You can't change the energy variable definition. Setting it would break the rest of the game code. You must convert the value when calling display energy. So you're telling me I can't do this? I can't just do... I can't just do this? Can I just do that? Yeah, I can just do that. Okay. So in our games shop, we want to let the player type number to select the number of items they want to buy or sell. We need to know the number of items as an int, but the computer reads the player's input as a string. Your task is to convert the player's input into numbers for the shop's code to work. Using int function, convert the player's input into a whole number and store the result in the item count variable. So it says player input is that, item count this, then by selected item, player input is that, and then so item count is plus equals to int of player input, like that. Continue. Last lesson. This is the one that I wasn't sure what it was, but I'll probably... Wait, is this the last lesson? 27, right? Specifying types with type hints. By default, GDScript is what we call a dynamic type language. That means that you can just write variables, assign them to a value with a number, and assign them with another value with a different type. Unlike in some other languages in GDScript, the following code is valid. So func run var health equals to 100, health equals to some text, print health, and it turns into some text. So, oh yeah, so just changing types. But this feature often causes problems down the line. Let's take one example. Cell size, decimal number, or 2D vector. Games use grids all the time, be it for grid-based gameplay or to make algorithms faster. When working with grids, you need to convert grid coordinates into positions in the game world all the time. To do so, you can give each cell a size in pixels. You'd likely pick one of two types for that, float or vector2, because pixel positions on the screen use vector2 coordinates. Either of those two values would be fine. So var cell 50.50 and var cell vector 50.50. Okay. Using a vector2 could simplify some calculations. For example, when converting a grid coordinate to game world coordinates. So var cell size vector2 50.50 func grid to world cell return cell times cell size plus, okay, cell size, okay, got it. All right, got it. Because this is like vector2, it has a x and y in there, so it applies to that, and then turns that into 25 and stuff like that. Okay, in this example, because both cell and cell size are vector2 values, we can add them. How does it know that cell is a vector2 though? What if it's not? However, if cell size is a float, we get a type error. Okay. Oh, because cell, oh, okay. Because cell has a vector, okay, got it. That's what's inputted. Okay, so however, if cell size is a float, we will get a type error. Cell size equals 50, grid to world cell, return cell times cell size plus cell size divided by 2. Run, func run, grid to world, vector2 1 1. Invalid operands for operators. So this doesn't work because a cell is a cell size is a float. Okay. Oh yeah, and then you can't add it, right? Okay, got it. it messes up the number because once it tries to add, it's weird. So worse, due to dynamic typing, we can't get any error right away. We will only get the error when calling grid to world vector 211. And that's a big problem because we're learning we only have small code examples in this course, but your game's code will get long and split into many files. When coding, you often forget about the code you wrote several weeks ago. And with a lot of code, it could take hours of play before players trigger a type error in your code using type hints. Fortunately, GDScript has optional type hints. Type hints let the computer know the value type you want for variables and report the errors before running the code. To specify the type a variable can accept, you can write a colon and a type after the name when defining a new variable. So variable name is a type. Oh, okay. And then value. So pretty much you can tell the computer you want cell size only to accept vector 2 values like so. So var cell size, that's the variable, and then it's the type vector 2, and then equals to vector 2. Okay. If you try to replace the cell size with the value of another type later, the computer will not let you. So if you try to give it 50, you can't because it's supposed to be vector 2 type. So parser error, the assigned values type flow doesn't match the variable's type vector 2. So letting the computer figure it out. GDScript comes with a feature called type inference. In many cases, not all, the computer can figure out the type of a variable for you. To do so, you write colon equal without the type. The computer will set the type using the value after this equal sign. We can make cell size a variable of a type vector 2 like so. Oh, so you're skipping the vector 2 part because once you do the colon equals to it identifies this as vector 2. This makes little typing, yet you get the benefit of using type hints like the computer reporting errors better and faster. Why bother to add hints? When you give the language hints like that, it will prevent major type errors. When you work in Godot, you will see that the computer can report issues as you write the code. It makes the benefit even greater. Type hints can also help improve the readability of your code. It can help to put more information directly in the code. As we saw, types are essential when coding, and when using type hints, the computer will add them to the engine's built-in documentation system. There's an incredible third benefit for you by using type hints. You will learn types much faster. It's excellent for learning. In the following practices, you will write the correct type hints to make the code error-free. Okay. Our variables get the correct values but not the right hints. Using your type foo. Add the correct type names in the variable definition. You need to write the type name between the colon and the equal sign. Note, you cannot use the type inference in this practice. You need to write the type name in full. So using the type we need to write the type name between the colon and the equal sign. Okay, so this is vector 2, and then this one is text, which is a string, so it's str. Whole number is int, and this is float. Wait, is it not string? Go string. Is it not string? Okay, it is. Okay, capital S. Okay, got it. Continue. Alright. It is the other way around in this practice. The type hints are fine, but the values are not. Your task is to fix the value after the equal sign so they match the type hint in each variable. So int. I will give it... Oh wait, let me do... The string is hello world, and then int is 4, and then vector is that one, and then 3.14. I just swapped everything pretty much. Oh, 0.14. I just swapped everything. Well done, you completed the practice. Stay and play around, or continue the course. Lesson complete. Stay and revisit the study material or continue the course. You made it. Okay, nice. I finished. So you made it. Not only did you learn the foundations of coding, you're a big step closer to making your own game. Don't stop there. The fun starts now. So there's more stuff. But I'm done. I'm done. So yeah. That's pretty much it. That's everything. So I will end the stream here. Thanks for watching. But yeah. Thanks for joining. And I will probably take a break from like programming. I don't know, maybe I'll do more, but I haven't decided. Right now I just wanted to learn it, and then I'll make a game in the future maybe. But then yeah, I'm gonna make a game in the future, but I also want to play some games because I haven't streamed any games lately. But yeah, I'm gonna end stream here, so thanks for watching. Bye.